The last way we have to think about our cell size and resolution of our output raster is when we're converting point data to raster data. We have seen a bunch of different tools in the past couple weeks with interpolation and density tools that are creating raster outputs from point data. And in those examples, we kind of just made some general cell size choices. So I'll show you here how to make more informed cell size choices. Of course, if you know that you have one set of point data, like locations of potholes, and you have your elevation data at 30 meters, then you can just go ahead and skip right to using your point density or kernel density tool and use 30 meters as your resolution. But let's say you have all point data, or you just have one point data that you're trying to figure out what's the best resolution for my density output or my interpolation. So here we're looking at points of potholes, and we're just looking at pure density here because we don't have any values associated with them. I did do this with temperature data, which we can look at in a second too. But this is just pure count presence of potholes. We can start by determining the appropriate cell size for our point data by basically the suggestion is producing a digital elevation model or a raster output at the cell size you anticipate needing. And then we can evaluate the appropriateness of that cell size. So to evaluate our raster output, we start with our point to raster tool. Since we don't have any values, I'm just looking for raw counts. I'm leaving this as the object ID. I'm going to change this to, what am I changing this to? So this is going to be, has to be, so this is foot data. So we're going to put 30 meters, which is 98 feet, I believe. Yeah, 98. And we are going to use a cell size count because we just want to know if you had a value, like if these were all temperature data or air pollution data, you could use that. It would tell you, do we have a point with a value associated with it in that field? But here, I'm just using the object ID because I just want to count the presence for my density tools. So when I went ahead and clicked run on that, I already did it, spoiler. And you can see that we get this output. Let me turn the points off and change the symbology. Oh, I should turn it on maybe. Oh no, that's the, oops, wrong one. That's our problem. I'm changing the symbology on the wrong one. Okay, unique values. Okay, so we have all sorts of data that pops up. And what are we looking at? We are looking at a count that's telling us how many points fall within each cell. And since we're just doing presence or absence, these are telling us more or less. Actually, let me reverse this real quick. Let me reverse my color scheme. Okay, so I switched my symbology and I turned on the gray base map so you could see a little bit better. But what we're seeing is every grid cell, if we chose a 30 meter grid cell size for our area, every grid cell that has counts. So we have a count variation from 1 to 140. So some of these darker cells have 140 pothole records over those 4 years. It's going to stay in here. No. And we can see that we have a pretty good spread of the data. There are a lot of points within cells, but we still have a lot of cells that don't have that many points in it. So we could, if we wanted to, go through this process again, change our cell size to be 100 meters, which is 328 feet, 328.0. We can run this again, and we'll end up with this output that you saw before. Let me adjust that symbology to Nope, that's not what I wanted to do. I'll just change it this way. It's going to be slightly different because this is what I could easily find. But, so now we see we have values from 1 to 173 versus 140. So we have more, higher values, higher counts. So with a greater cell size, we're seeing, let me back up, we're seeing even more points within each cell. We can definitely see some of those. I just want to turn off the labels. There we go. We can see, you know, there's a lot of areas that have more points in our cells. Our count values, like I said, range from 1 to 170. So this is telling us we could maybe use a smaller cell size, but this could work as well. We could, you know, go up another grid cell size to see what would be the best for our density tool, but this is always a great place to start. Definitely, I think, better than our previous option, because we just have more coverage of the data. We have a lot more higher values, and we have a lot more variation in our point data. Now, what you would do from here is we could go into our geoprocessing tool. We could look up our kernel density tool, and knowing that the 328 is it, did I say 320? Yeah, 328 feet for that 100 meters would be our best output cell size. We could add that in here. You also could, if you wanted to, start at the 100 meters, or start at 50 meters, whatever you wanted to look at. And this could be later resampled. So if we stayed with that 100 meters and realized, we needed coarser scale data, we just could even use coarser scale data, we could go in and resample based on the other examples like we've seen before on resampling that data. What else did I want to show? Let me look at this one. So this is what we looked at with temperature data. This is if you had a value. So temperature data has a value associated with it. So it has, our average temperatures. I tried to use this one at first by using that 100 meters. But as you can see, the 100 meters is obviously way too small. We're getting too much. Yeah, they're there. You're getting it's way too small. You're getting too many areas, way too sparse of data. This cell size is inappropriate for this data set. I then bumped it up to 50 kilometers, from 100 kilometers. From 100 meters, I should say, just to kind of basing at some of the distance between the data sets. And you start to see that we had more data counts. We had higher counts, so now we go from 1 to 4 instead of just 1, but it's still not a great set of data. One thing to think about, though, we're not going to be using point to raster here. For temperature data, we're definitely filling in the different distance, the points between the known points. We're filling in all that data. So, this would give us maybe a good idea for output cell size, but knowing that, I don't think we could definitely go higher than 100 meters, but less than 50 kilometers to create that. Yeah, so a little bit more complicated when you're using point data. You have a couple more choices to make, but it's good to start thinking about how you would choose your resolution and what's appropriate. So, of course, always depends on your computer speed, the available data that you have, and the scale of the phenomenon that you're studying.